Hey everyone, in this video, we're going to talk about how to graph quadratic functions. And so you're going to be given two different forms of your quadratic function, either vertex form, or they call it general form, but I always call this standard form. Vertex form is a little bit easier because, as its name suggests, it gives you the vertex. So when you're given the vertex, you're going to see some parentheses, and then your vertex is HK. So notice that your H here is in the formula is a minus H, but in the vertex, it's positive. You're always going to switch that sign. So if this is minus 5, then this is 5. If this is plus 5, then this is negative 5. You have one that's a negative H, one that's a positive H. So you're switching that sign. And then your K is whatever's not in parentheses, and it will have the same sign. You've got a plus K here. So this is a K here. And then you have something called axis of symmetry. And your axis of symmetry is always going to be X equals whatever your H is here. So let's kind of review and go back for a second on what a quadratic is. And so if you come in here and just put in the most basic quadratic, which is X squared, here is your graph. And so we call these graphs parabolas. You can see it right here, parabola. That's not parabola. Okay, it's not a disease, but you have a parabola. And so these are two important things whenever we're graphing. The vertex, in this case, is the lowest point here. So it's wherever it's like here, it's going down. And now here at the vertex, it changes directions and now it goes back up. You can also have a parabola that is upside down. And now that vertex is the highest point because it's again changing directions there. It's going up, now it reaches the top, and now it's going back down. So we want to be able to determine where this vertex is. And then this axis of symmetry is basically right here, my y-axis. It's where it is mirroring. So you can see here, it looks the same over here if you take it and you flip it over. And so we want to be able to find that axis of symmetry. Now, again, vertex form is really nice because it tells us the vertex. When you're given general form, or what I call standard form, now this is what we're used to. This is how we have quadratics when I want to use the formula. This is what it needs to look like when it's factored. Your ax squared plus bx plus c. So you have parentheses, which is vertex form, versus no parentheses, which is general form. When you're given general form, you've got to do a little bit of work to find that vertex. You've got x equals negative b over 2a, and that will get you your x coordinate. And then to get your y coordinate, you need to plug in whatever number this is. And then your axis of symmetry is, again, whatever your x is. Okay, so these are kind of the two different forms we're going to be graphing in. One gives you the vertex, one you have to find the vertex. And then here's some more information that it's going to be asked, and it's just good to know. You can determine if the parabola opens up or opens down by looking at your A. So if A is greater than 0 or if A is positive, it's going to open up. So if A is less than 0 or negative, then the parabola is going to open down. Okay, and this is your open up, your open down parabolas. We're also going to need to find the x-intercepts of the parabola. So it says, given the quadratic equation, you find the x-intercept, if there is one, by letting y equal 0 and solving for x. We have three ways to solve quadratics, and that is by factoring, using the square root property, or I think I called it square root method, or the quadratic formula. We are going to be using all three of these to solve one problem or another for finding the x-intercept. Now, with the x-intercepts, there can be as many as 2 x-intercepts. There can be 1, or there can be none. And so I have kind of doodled some examples of 2, 1, and none. When you have 2, it's going to look something like this. If it opens up or opens down, you're going to have it going up with the vertex below the x-axis, or if it's opening down, you have the vertex above the x-axis. You can have one where the vertex of your parabola is your x-intercept. These are kind of rare, okay, but this can happen. So if your vertex is your x-intercept, then you have one x-intercept. And then you can have none. And when you have none, you're going to have the entire parabola on top of the x-axis or below. When you get these here, whether you're solving by, really, you're not going to be solving by factoring, but if you're solving by square root method or the quadratic formula, you're going to end up getting a square root of a negative number, which then equals your imaginary number. And so when you are using the square root method or the quadratic formula and you get the square root of a negative number, that means you have an imaginary number. And so that's how you know you've got your x-intercepts or no x-intercepts, okay? So that's what it looks like when you've got none, 1, and 2. I would say 2 is going to happen the most. And then you have determining the y-intercept is opposite. You're not going to let x equal 0 and solve for y. Because these are functions, you will always have one y-intercept. So if I come back to these right here, you have an x-intercept here. You have an x-intercept here, or sorry, y, goodness. You have one y-intercept because it's crossing the y-axis, Here, it's not looking like that, but this is eventually going to go up and out, and then it's going to cross. Here, you've got 1, you've got 1, and you've got 1 y-intercept. You will always have 1. The x can change between 2, 1, and none, but this one is constant. So make sure you've got all of this wrote down. This is the information that we're going to need to do the rest of this lesson. And once you got this copied down, then let's move on and do some examples and actually use this.